Hello. Let's talk about two problems from this homework assignment. These two problems are interesting in the sense that we're gonna use basic tools we covered in the class, but you need a little bit uh, more thinking beyond the basic setting. The first problem. An urn initially contains 7 white balls and 9 green balls. Each time a ball is selected, its color is noted and it is replaced in the urn along with 3 other balls of the same color. Complete parts A and B. So you pick a ball and then you record the color and put it back, and then put another 3 balls with the same color to the urn, and you do it again. Okay. A, compute the probability that the first 2 balls selected are green and the next 2 are white. For this problem alone, actually, you can do it directly using sort of a conditional probability. But the next problem is a little bit more complicated. So I'm going to just use one tool we can use to solve both. The tool is the tree diagram. So this problem is actually not exactly base problem. It's a tree diagram problem. Right? There's no base, no posterior probability that is involved. Okay, so let's draw a tree. There are 4 steps, so we needed some space. All right, let's use a line. Okay. So the first step, we have there are 2 kinds of balls, 2 colors, white balls and green balls. Y, let's put 1 here. And green, and that means the first ball, okay? And we have 7 white balls and 6 green balls totally. So it's 7 out of 16. There are 16 balls totally. And then here, green is 9 over 16. Okay. Now, once the first ball is picked and it's white, then 3 more white balls will be added. So here we have 7 white and 9 green. But now we have 7 plus 3 white balls. So you have 10 white balls and 9 green balls. Okay. And here, if the first ball is green, then we would have 12 greens because you have 3 more. Put the first one back, right? So yeah, 12 greens and 7 white. So total you have 19 balls. Okay, and then we look at the second step. And again, we have a white and green. So now the second step with white, green, white, and green. Actually, we need to draw 3 balls. So sorry, 4 balls totally. So it's a little bit for 4 trees, 4 branches, I mean 4 layers. It's a little bit more complicated, but you run the same scheme. It's not very difficult, but I would say it's complicated. Okay, so now we have if the first ball is white, and what's the probability that second ball is white? You have a 10 out of 19, right? You have a 19 balls totally, and 10 are white, so 9 green, so 9 over 19 here. 9 over 19. And similarly, you have 7 white balls and 12 green balls. So 12 out of 19. Now here, let's keep track of all the white balls and green balls. So after second white ball is drawn, you're gonna have 3 more white balls. So you have 13 white balls and 9 green balls. And for here, if the second ball is green, we have 12 green balls, and then you have 10 white balls. Again, you have 22 balls. And if the first ball is green, second ball is white, we would have 10 white balls and 12 green balls. And here, green, green. So you have 15 green balls and you have 7 white balls. All right, you keep doing that. I hope we have space to finish 4 steps. W3, green 3, Y3, green 3, Y3, green 3, Y3, green 3. Okay, so now we have white 13 out of 22 and 9 out of 22. So here you have 10 out of 22 and 12 out of 22. And for here you have a 10 out of 22 and I'm squeezed. And you have 12 out of 22, and then you have 7 out of 22, 15 out of 22, okay? All these probabilities are conditional probabilities, conditioning on W1, W2, okay? Conditioning on the first 2 steps. And then we mark, we keep track of the balls, right? So you have 13 white balls, 9 green balls, but then you have another white ball selected, but 3 more, 16 white balls, 9 green balls. And this one you have 13 white balls and 12 green balls. And for this one, W3, you have 13 white balls and 12 green balls. And then you have 10 white balls, 15 green balls. Add together, you get 25 balls. And then you have 13 white, 12 green. Yeah, I need some more space. Here you have 10 white, and then you have 15 green. And some situations are similar, but 10, 10, 10, 15, 10, 15. Now let's not try to find some pattern, just do it like, bash it out. Okay, so W3, what do I have? You have 10 white, 15 green. And for G3, you have 7 white and 18 green. All right. Okay, finally, we have, let's see, another, let's just do something like that, make some space. All right, really squeezed. I need like 16 here. All right. I don't think I need to keep track with the number of balls after 4 steps. I only need the probabilities. So I'm gonna, it's a bit tedious, okay? But it's not difficult. W4 and G4. W4, G4, W4, and G4, okay, squeezed. Then I have 16 out of 25, 9 out of 25. Okay, maybe I should just write right here. So I keep some, have some space. 16 out of 25, 9 out of 25. And then you have 13 out of 25, 12 out of 25. And then here you have 13 out of 25, 12 out of 25, 10 out of 25, and 15 out of 25, and so forth. 13 out of 25, 12 out of 25, 10 out of 25, 15 out of 25. And then you have a 10 out of 25, 15 out of 25. Okay, I really need some space. 7 out of 25, and then I have 18 out of 25. G. Okay. So what do I have here? What do I looking for? Compute the probability that the first 2 balls selected are green and next to a white. Okay, so the first 2 are green. So green, green, and next to a white, white, white. Right? It's an intersection of all 4 situations that you use product rule for these 4 sets, and then we would get the answer, just multiply, it's a product rule. So I have 9 over 16 times 12 over 19 times 7 over 22 times 10 out of 25. Okay, 10 out of 25 is here. All right. Type an integer or decimal rounded to 6 decimal place. Okay, I think we're gonna just put in the calculator. All right, 9 divided by 16 times 12 divided by 19 times 7 divided by 22 times 10 divided by 25. That's 0.45, 0.04, 0.045 21531. Keep 6 decimal places as needed. So let's type in 0.045 215. I need 0.045 215. Okay, so that's our answer. All right, so that is correct. Let's click on OK, and then move on to the next one. It's a little bit messy here, but I think we can read. Compute the probability that or of the first 4 balls selected, exactly 2 are green. Okay, so exactly 2 are green. All right. Let's use different color G. I wanted to get rid of this, and I probably still need to use that, but anyway, exactly 4 greens. WWW, that's not good. WWG, GG, so that's good. This is what we need to keep. WWGG. And WGWG, that's we need to keep. And WGGW, that's gonna keep. And then GWWG, GWGW, GWG, yeah, that's already there. GGWW. Okay, 1, 2, so 6 of them. You can use the counting method to argue as well. We have totally 2 G's and 2 W's. So you have a 4 factorial over 2 factorial times 2 factorial. Okay, 4 times 3 times 2 times 1 divided by 4. It's exactly 6. So 6 possibilities. All right, so now we have what? We have a 7 out of 16 times. Gee, I really needed to, probably I should do that. All right, 16 times. 7 times, 16 times 10 over 19 times 9 over 22 times 12 out of 25. Okay, I'm gonna pause and then I'll finish the leftovers and then go back. Okay, so I worked it out. And you probably have noticed that all the numerators are 7, 10, 9, 12, and they change the order, and they're the same. And the bottom are the same, 16, 19, 22, 25. It's not out of nowhere. And actually, there's some reason behind it. You can consider the bottoms will always be the same, right? No matter what, you have a 4. You add 3, add 3, add 3, add 3, and 4 times. All right. Actually 3 times, add 3, add 3, 3 times. And the order, the sort of interchangeability type of properties involved in these selections. I don't want to get into details. I think there's a way of proving it, but we bashed it out and it appears that they're all the same. So I just multiply the number from A by 6, we would get the answer for B. Okay, so let's do that. 0.27192. All right, so we're done with this problem. Okay, next problem. Of all babies, 97.8% survive delivery. I think there's an error here. I mean, survive delivery. I think that's a repetition. However, 15.2% of all births involve cesarean C-sections. And when C-section is performed, the baby survives 96.1% of the time. If a randomly chosen pregnant woman does not have a C-section, what is the probability that her baby survives? Okay, so there are 2 types of things. One is C-section or not, and then you have survive or not. It's very helpful to draw a tree diagram. So we're going to do that. All right, so there are two situations, C or no C, right? And then survive or not. Okay. So you have a C or a C not. And then you have survive or not. All right. And we have on this probability is the probability of S. It's kind of total probability. Normally, we are looking for this given all the numbers in the tree, but this problem is actually that you need to work backwards, sort of solving an equation type of problem. Okay, so 15.2% of all births involve C-section. So I have a 0.152 and then 0.848. Okay, and then if there's a C-section and the baby survives with probability 0.961, and not survive would be 0.039. And if there was no C-section, what is the probability that the baby will survive? That's exactly what we're looking for. So we have X here. You could put 1 minus X here, but it's probably not important because we know the probability of S is given. So probability of S, by total probability, I'm going to work a little bit more with more details. S intersect with C plus the probability of S intersect with C prime. It's the partition, right? C and C prime form a partition. And then we use the product rule. Okay, so this is so-called total probability. And we know PS 0.978 and the probability of S given C 0.961, which is here. Okay. And the probability of C is 0.152. And then this is not is what we're looking for, right? Probability of S given C prime. And then probability of C prime, we know that 0.848. So we solve for X, all right? And I'm going to pause, use calculator to find it. All right, so I used the calculator to figure out this X. It is 0.981047 and keep 4 decimal points. So I'm going to put 0.9810 there. And then let's see if it is correct. All right, I think we're done with these two problems. I hope that you get some help from it. All right, thanks for watching. Bye-bye.